Hello everyone, this is Ananya Das on behalf of Team C, hereby presenting you with the DIY Lab Team project my team has been working on under the field of automation, which is GSM based SMS alert fire alarm system using Arduino. Before I get into the project, I would like to express our special thanks to our DIY lab professors, Professor Vikrant, Professor Jayanaran, and Professor Sandeep Shah for their able guidance and support in completion of this project successfully, and also for giving us a chance to learn so much, and it was such an amazing experience for us. Every now and then we come across articles about fire incidents. Here I show you with some recent ones. Daily, around 100 fire incidents are reported only. Most of them are fatal to human life and property. And this is what alarms us that we should have a well developed system which can alert us so that we can avoid these losses to human life as well as property. So we searched for some existing fire alarm systems, some basics and some advanced ones too, and we tried to develop an advanced and accurate fire alert system which is not just accurate and advanced but is also affordable and cheap for everyone and can inform anyone regardless of location. So we see that fire alert systems are of great importance even in this technologically advanced area, especially in this technologically advanced area. And speaking of technological advancements, there's just this one thing that pops up in our mind almost instantly. Yes, smartphones. So we thought, why not combine our need of fire alert systems with our smartphones? This way we can be warned any time of the fire wherever we are at the moment. Isn't it fascinating how we can be able to prevent a fire regardless of whether we are actually present at the site or not? Yes, it is. And that's why we decided to go with this idea. So basically, this is a fire monitoring system which can detect if there is a fire or not, measuring some parameters. For our project, we only consider two parameters, that is smoke and flame. So if this smoke and flame value goes beyond a certain threshold, the system interprets it that there's a fire nearby and starts to do its job to alert people by buzzers and LEDs. We have also incorporated GSM module in our project so that an SMS can be sent to desired authorities or owner of the place if the system detects a fire. For taking the input about environment, there are two sensors which we have used in the project. The first one is the flame sensor, and the second one is the MQ2 gas sensor. Further, these data will be interpreted by Arduino Uno, and for the output, we used LEDs, buzzers, and GSM module, as I explained before. A green LED is used to display when no alert is there, and a red LED and buzzer informs about the fire. GSM module contains a SIM card which is used to send text messages. But all the information sending the text SMS, such as the contact number of the people and how many times the SMS needs to be sent, is with the Arduino. So we developed a kit for the fire alert system and we tested it under some conditions, first on stimulation software and then physically, and then we got the desired results. There are various types of systems used for fire alarm systems. So, a basic fire alarm system consists of some smoke sensors and buzzers. So, if some smoke from fire is detected, the buzzer beeps and people in proximity are notified about it. Now, this is not an advanced type of fire alarm system as there's always a chance of malfunctioning of sensors and manual input is always not accurate. So a more advanced solution used for fire alarm system is fire control panel unit. They have a huge network of detectors so that the fire can be detected easily. Besides alerting people through speakers and buzzers, they also have some arrangements to control fire. Some upgraded versions of these FCPs, which are too costly and big and are used in big industries only, has some arrangements for alerting some people such as owner or security regardless of their location through SMS or call. As these fire control panels are a reliable solution, but because of their high cost and big sizes, these can be used in industries and offices and not in residential areas. It also requires a huge cost for maintenance and repairing purpose also. Now I show you some advanced fire control panels. This is a basic circuit. It has so many detectors as you can see. But we found many advantages, like for the basic fire alarm systems, they are not really reliable. There's a high chances that it might not be able to inform us if a fire occurs. And even if fire control panels are reliable, they are huge and are very costly and cannot be afforded for normal households. So we tried to achieve a solution which has a accuracy like fire control panels and is also cheap and affordable. So we worked together in our team to develop a small kit using Arduino first, smoke and flame sensors which can be used to alert user before any fire incident. And here with our project GSM based SMS alert fire alarm system using Arduino, we tested it and we succeeded in finding a better solution for fire alarm system which is compact, low cost, advanced with technology and accurate. Some of the key features of our project is that as I have already mentioned a few before, that it is compact, user friendly, low cost, long term solution for fire alarm system, easily calibrated according to the environment, more accurate than previous solutions, and advanced. And it alerts anyone regardless of their location as GSM modules used SIM cards to send text messages. So the materials required for our project are Arduino Uno, a GSM module, a flame sensor MQ2 and a MQ2 gas sensor, LEDs, buzzers, jumper wires, breadboards, USB cable and adapter. Here are the specifications of the Arduino Uno Atmega 320p that we used for our project. Here's the photo of that. The features and technical specifications of the Arduino Uno includes these. Now, coming on to the SIM 900A GSM module. These are the specifications. Here's the photo of the GSM module that we used. And these are the features and technical specifications of the GSM module which we used in our project. Now, coming on to the IR flame sensor. The IR flame sensor is used to detect the presence of fire or other infrared source, flame or light source of wavelength in the range of 760 nanometer to 110 nanometer can be detected. Here's the photo of a IR flame sensor, and these are the features and technical specifications of the flame sensor that we used. Now coming on to the next and final sensor that we used in our project, the MQ2 gas sensor. These are some of the specifications. Here's the photo, and this is the features and technical specifications of the MQ2 gas sensor that we used for our project. We also used LEDs, green and red, for our project. These are the features and technical specifications of the LEDs that we used. We used buzzers, of which the features and technical specifications are included in the following: jumper wires for connecting through the breadboard, here's the breadboard for which the jumper wire was required, and the features and technical specifications of this breadboard are given. We also used USB cable to connect Arduino Uno or any board with the USB female, a cable length is approximately 1 meter for our project. We also used adapter to provide power supply to GSM and Arduino Uno. It provides a constant DC supply of 12 volt and 1 ampere current to the circuit. Here are the features and technical specifications of the adapter that we used. So next we come on to the flowchart and circuit diagram for our project. So first of all, the input is collected from the sensors. The two sensors that we used are the flame sensor and MQ2 gas sensor. The Arduino Uno collects this data, processes it and interprets it. Now, if a threshold is not crossed, then the fire is not detected and no display alert will be nearby, and people will go just see the green LED. If, however, the parameters value exceeds the threshold, a fire is detected by the system, and the nearby people will be alerted through the LED and buzzers, and the GSM module will also send a text alert to the user, which can be an owner or any designated person like security. This is basically the circuit that we used for our project. Here are some of the photos of how our project looked after the assembly. The code we used for Arduino, it's here. This project was tested many times in different conditions by calibrating it various times according to the environment. And after a few initial unsuccessful attempts, we were able to get desired output through the project at the end. This is the video link which is shared with you for the assembly of our project. So further improvement that can be achieved in this project is the output. This output can be displayed on a LCD display through some software like Proteus or a Node-RED. A manual switch can be added to be used to send alert in case the sensor stop gives alert whenever needed. So for the first week, we collected information about various existing fire alarm systems, and we analyzed them, and we tried to think of what improvisations we can do over on this project. In task 2, we set our goal and goal for what improvisations we need to achieve for our project, and we created a list of materials which were required, and we also ordered them. Then in week 3, we developed some small circuits related to our projects to study the working of various components used in the project, and developed a small circuit for our project. Uh, in this week, we faced various difficulties with the codes, with various technical difficulties, but we were able to overcome it. In week 4, we created a circuit for the project, assembled the components, tested the project, calibrated the sensor reading according to the surroundings, and created the final project report. So there's a lot that we got to learn from this project. Since none of us had any experience in working with Arduino or any other components, it was our first time. So we got to know about Arduino, how it works, programming in Arduino, and how to tackle the various errors that we were finding, and how to debug them. Also, we got to know about GSM module and other sensors. We learned how they work and how the physics around it works. Although we faced many problems while doing the project, which arise due to the errors in setup and program, but all of this helped us to learn a lot, and it made and finding the solutions to these various problems also kept us engaging and made this project even more interesting. Moreover, we learned how to teamwork through this project. It was very necessary since this is an online sim. At last, we got to learn about a few new things which helped in completion of this project successfully. So these are my team members, Hariom, and these are the contribution made by them. Hariom developed and assembled the complete project. He also tested it. Yashwant and Lavrudra collected information and helped in report making. I, Ananya, helped also helped in collecting information and did the presentation part. So these are the sources from which we tried the initial circuits before starting our main project, and the links are given here. So this is the project by Team C, which consists of Hariom, Yashwant, Lavrudra, and myself, Ananya. That's all by Team C. Thank you and have a nice day.